The broadcast is now starting. All attendees are in listen-only mode.
Okay, welcome everyone. Hello, sorry for the delay in getting started today. Welcome to our webinar on communications options for ITS projects. We have 4 panelists on the line and more than 100 people registered for this webinar, so we're going to get started now, and thank you to each of you for joining us today. My name is Jenny Kutz. I'm the marketing manager here at Rhythm Engineering, and I help to plan and coordinate our monthly webinars. Our goal with these special topic webinars is simply to provide valuable information that helps you. We stay on top of everything that's happening in the world of traffic technology, and we're happy to make these webinars available so that you can stay informed of the latest developments in this field. I think you'll find that you've walked away from today's webinar with a lot of new information and a better understanding of what your communications options are for ITS projects. So just a few administrative announcements before we get going. First of all, because of the size of our webinar audience today, we do have everyone muted except for the presenters. And this should minimize interruptions and make it easier for you to hear the presentation clearly. While you are muted, that doesn't mean we don't want your participation. We absolutely do. So please feel free to ask questions at any time during the presentation. You should see a questions panel on your screen in the GoToWebinar control panel. Since we have experts in different areas today, please try to specify the name of the person to whom you're addressing your question. That will help us out greatly. And we will do all questions and answers at the end of the presentation. Finally, we are recording today's webinar, and we hope to make it available to you as a video that we'll post on our website. We'll send you a link to that video later this week. So if there's something on the slide that you missed, that you didn't get to write down, don't worry, you will have access to it again later after the webinar. So finally, without any further ado, I'd like to introduce our moderator, who's also a colleague of mine. Steve Penrod is Vice President of Engineering here at Rhythm Engineering. Steve has 20 years of experience as a software engineer, developer, and programmer. In his role, he oversees our company's research and development team that is working hard on a series of groundbreaking traffic technology product releases for 2011, and we're glad to have him moderating this webinar today. Steve, welcome.
Thanks a lot, Jenny. Hello, everyone. Today, as Jane said, there are 4 of us making presentations. I'm going to just do a general overview of internet technologies for those of you who don't have a lot of experience with working with networking, and give you a feel for what it is and how it will actually be used in the ITS space, how it would be useful for you. And then we will have experts on some of the specific technologies that get deployed, fiber, copper, and wireless technologies that will each speak to those particular areas and a little bit about their particular products that their companies produce. So first I will talk about a thing that you've probably all interacted with called the Internet. The Internet the origins of it came back in 1973. There were actually preceding what we think of today as Internet were several small fractured ARPANETs and things like that were small research areas, academic research, a little bit of military usage, where they were trying to figure out what was the best way of doing it. And they created this thing called TCP/IP for a bit of trivia. That's Transmission Control Protocol, an internetwork protocol. That's what allowed these different networks to function as a whole. And that really has become the basis of all the technology that we see today. It's based on a thing called packet switching technology. Previously, there were things like, if you think of an old-fashioned switchboard where someone would physically make a connection between 2 parties, and that's how a lot of transmissions were handled. And so that line was dedicated to exactly what was plugged in on both ends. Packet switching technology makes use of breaking things into little hunks, little packets with an address of where the packet is supposed to go to. And each individual packet is then sent out and goes across whatever the networks exist between the two ends, and they arrive there almost magically. And then it's up to the client at the end to reassemble these packets and to make use of them in whatever way is appropriate for what you're trying to achieve. One of the advantages of a packet switching technology over the dedicated technologies of the past is that if something happens to a link where the link gets broken during this conversation that's going on, it almost instantly adjusts the routing and works its way around wherever that failure point is. If there is a way for the 2 points to be connected, the packet will figure its way to make it around that break and to get to its final destination.
Steve, I don't mean to interrupt you, excuse me. I see your slides not changing for our audience. Maybe we just want to refresh the application here.
Let's see if this
Let's try this so you can see the slides that we're presenting here.
There we go.
We got it now.
Yep.
Okay, excellent. So this packet switching technology in TCP/IP caught on. It's been adopted by military and universities, and then started to spread to, well, the world now. Everything you see on your computer practically makes use of TCP/IP in some form. And one thing that some people misunderstand is that while this is the Internet protocol, the Internet does not necessarily mean in this terminology the entire world can get to it. Private networks can make use of the exact same technology. They're just not connected to an outside network. So this is both public and private networks make use of the Internet protocol. Now the number that you will see on your screen here is really kind of the core of what makes the Internet protocol, what makes the Internet work. It's like a phone number or a house address. It's a unique address. Every item on the network has to have a unique address that allows the system to figure out where it's got to deliver its packet to. There, you will run into this for all the familiar technologies that you use day to day. You know, the web, email, chat. Even right now, what we're doing right now with GoToWebinar is making use of TCP/IP. Each one of the words that I say, all the sounds that's coming out, all the images coming across is being broken into these little packets, and they're zipping across the wires and making it out to you through these addresses that it knows where I'm sending it from and where it needs to get to in the end. One of the other unique and interesting things about this whole approach is that those packets don't all have to be used for the same purpose. So a single connection can carry packets for multiple protocols. For example, you often use your computer to browse the web and to listen to music and to send email and to watch things such as this presentation. All of that is going across a single wire coming out of your computer. You don't have to have a dedicated line for each one of these things. So it's a very flexible mechanism for connecting up devices. It doesn't really matter what the devices are. As we said, this has been in place since 1973, the basic protocols, and obviously a lot of technologies have changed between now and then, and things that they had not even dreamed up in the 70s have been created and have made use of this basic networking technology. Another thing that you might hear when you're, especially as you're looking at new projects and future support, the address that is visible up there is what we call IP version 4. Those 4 numbers separated by dots. That is functional and has been used for many years. but there are concerns about the world basically running out of numbers. There have been some workarounds that allow us to cheat a little bit and to reuse some of those numbers in private networks. But you will hear people talking about IPv6. It is currently not a commonly used technology, but in the future it will be more and more common. You'll at least hear people talking about it. And essentially the difference between the IPv4 and the IPv6 is the length of the address. Instead of it being 4 bytes, IPv6 is actually 4 times 4 bytes. So to kind of put that in perspective, that would be enough addresses to give every single individual on the planet 2 to the 95th addressable devices, or that's 2 to the 95th is such a huge number, it's hard to grasp. 2 to the 20th is 1,000,000. 2 to the 30th is 1,000,000,000. So 2 to the 95th is a really, really amazingly large number, and that's what was available for each individual on the planet. So it's unlikely we're going to run out of addresses once we've made the leap to IPv6. But as I said, any projects you're doing in the near future, it's unlikely that you'll make use of that technology quite yet. Now, anytime that you start working outside of your traffic cabinets, for example, you're going to run into what's called the IT department. They're really not bad guys. They have a kind of a tough job in that they are getting everyone to work together. Once you get outside of your own small area, you have concerns about overlapping addresses with other people. You have concerns about security, and it's really their job to make sure that all of these things get handled. The assignment of the IP addresses, while it sounds really simple, is actually worth consideration. There are various things to worry about because while it's easy to just give a device an address up front, it can be a lot more difficult to go back and change it. And so when you're first planning these sorts of projects, you want to give yourself some room for future devices that you might plug in. For example, you might only have 2 things that make use of IP plugged into a traffic cabinet today. But I would recommend attempting to reserve maybe 8 addresses or 10 addresses for that traffic cabinet. You'll be surprised if once you get used to the flexibility of the IP schemes and the capabilities of TCP/IP, there's so many different devices that you can use to adapt things that, for example, an old serial device, you can plop an adapter on that, and suddenly that serial communication can be carried across your TCP/IP connection, and you're able to talk to multiple serial devices within your cabinet. So you can pretty rapidly erode away those 5 or 10 addresses. Another thing that IT departments particularly get worried about is security. You have to realize that a network is a network connecting everything potentially. And the original design of the internet was to allow anyone, anywhere to get to anything. And after the fact, they realized that that wasn't always a good idea. So they started creating things like firewalls that allow you to restrict the traffic between 2 different connections. So you can limit what kind of traffic gets through. You can limit even down to the level where you can specify which devices on one side are allowed to talk to which devices on the other side. These are definitely concerns in that you don't want someone, for example, breaking into a traffic cabinet at the side of the road and being able to plug in their laptop and get to the county tax record sitting in City Hall. So that's where the IT department is really going to get involved to make sure that you are not inadvertently creating security holes like that have much broader consequences. But it is also possible, for sure, to allow connections through secure mechanisms like VPN or virtual private network, so that even though your network is secure, it is possible for the appropriate individuals through username and password controls and such to be able to get to the networks that they need to. Now, I'll talk a little bit about networking hardware at an abstract level. Another amazing thing about the whole TCP/IP scheme is that truly the network does not care about what they call the transport mechanism, what's physically connecting stuff up. It doesn't matter whether you're talking over a Ethernet twisted pair copper, whether you're talking over a fiber optic line, whether you're talking over wireless radio link. There is early implementation of TCP/IP even worked on some shortwave radios. There's all sorts of mechanisms that can do it, and the high level does not care about what is physically connecting things beyond the bandwidth requirements. That's where you do have to start worrying if you're doing something that needs a lot of speed. The good thing about this is you can use the right technology where appropriate. If you have existing copper lines, you can make use of those lines. If you need higher throughput, maybe it makes sense to pull in a fiber optic cable. If you have difficulty bridging a chasm, perhaps there's a literal chasm between 2 points, you can use wireless technology. And it's all up to the routers, which are those little pieces of hardware that you plug the cables into. It's all up to those to do the translation and to figure out how to work with the specific hardware that is actually carrying the signals for you. But as far as the network is considered, the hardware, the mixed hardware in the environment is totally transparent. And this also gives you the flexibility in the future to switch if you determine that part of your network needs more throughput capabilities. You can switch to a different technology, or if you're having a difficulty for some environmental reason interfering with a radio transmission, you can switch to a fiber transmission mechanism, or whatever works for your particular situation. You can make these changes without having to change your overall network design. So with that, I'm going to hand this over to one of our experts. We'll start with our expert in fiber, which is Jim Krashenfels. He works for Garrettcom, and he directs the marketing department for Garrettcom, which is a leading provider of hardened network equipment. Jim has over 10 years of marketing and product management experience in the networking industry at Garrettcom, Cisco, and Speedcom Wireless. Currently, his responsibilities include the development and execution of Garrettcom's marketing strategy and programs. Jim, welcome. Take it away.
Great. Thanks, Steve. Just a real brief sanity check. I want to make sure everyone can see just my PowerPoint slides on the screen. Is that the case or no?
Yes, that's correct. We
that
can
is correct.
see it.
Okay, fantastic. Okay, so take a look at fiber and networking. And let me go first to the agenda. Make sure everyone can see that. Jenny, can you see the agenda screen?
Yes, we can.
Okay, very good. Okay, so the benefits of using fiber will be the first thing I'll touch on. Then we'll go through Ethernet networking with fiber for intelligent transportation systems. Then talk a bit about the type of equipment you need. This is not something that on the West Coast you might go to Fry's. On the Midwest or East Coast, I'm not sure where you would go, but you want to have hardened equipment. So you can't just buy this necessarily off the shelf, because there are a lot of issues you need to think about when you're implementing your networking equipment for transportation. Then we can,
for a moment, Jim. Can I ask you to speak up a little bit? We're getting a few audience members saying that the sound's a little weak.
Okay, I've got my headset on. I'll try to pull the mic a little closer. Okay, so then after we talk about the Ethernet networking with fiber for ITS, we'll go into the hardened equipment, the applications, and the connection into copper as well. A lot of the products you'll use for networking will have both fiber and copper ports. So with that having been said, let's go into the benefits of fiber. So number one, and Steve touched on this a little bit, is security. In this lovely economy, no one ever got fired from implementing more security. Security, I go to a lot of trade shows each year, and the security trade shows are the ones that are either going strong or even growing in attendance. So security is a big aspect. Fiber. Fiber is more secure because it doesn't emit any RF energy. The only way to tap into it would be to physically cut the cable and install a splitter, which, by the way, is detectable with fiber test equipment. And the U.S. Department of Defense has used fiber cables for over 25 years. So that's definitely an agency or department of government that is interested in security. No electric interference. So a fiber optic cable will not generate any electromagnetic or RF interference. It also will not pick up any environmental noise. This is beneficial in areas that have high voltage or lightning. I have a slide in here later that focuses on an implementation in Florida. And anyone that's lived in Florida, it has some unique characteristics, one of which they have a lot of electrical storms and a lot of lightning. They also have humidity. We can talk about that. Another benefit of fiber is low attenuation. There's very little data loss as light travels through fiber. So it goes all the way through these long distances, kilometers we're talking about, not meters, but kilometers, without a loss in intensity. Space saver. So fiber optic cable is really small. We're talking about here width and diameters in size. And relative to copper and other media, it's really small. And in building conduits in areas with limited space, this can definitely be an advantage. Distance. Okay, I've got a couple of asterisks around this. The biggest single reason people use fiber in ITS and other networking applications is distance. And, of course, it's widespread use in Ethernet networks and the higher data rates you get with that. But the distance allows you to interconnect intersections and connect back to the traffic control center. So it provides a very important media type and when you're going and installing networking equipment at various intersections and traffic in different traffic environments. So fiber distances. So I put an asterisk on the last slide by distance, and distance is extremely important. We manufacture a lot of products that have both fiber and copper ports. Copper is great, especially at the local level. It gives you a good 100 meters, and there are a lot of copper ports built into the products at the local level, particularly the cameras and transportation control equipment. But fiber can give you the distance. What are we looking at here? Multi-mode, 100 megabits, that's 2 kilometers. At 10 megabits, by the way, it's the same, 2 kilometers. If we look at multi-mode gigabit, right here, that is actually a little less. That's interesting. It's 550 meters. So a lot of the switches and networking equipment that you would install in your networking environment can do 2 kilometers, but you have to request the ports be extended distance multi-mode gigabit to give you that 2 kilometers that you're used to and that you love for 100 megabit environments and 10 megabit environments. Now, single mode is a little different story. You can really get the distances there for both fast Ethernet 100 megabit and in gigabit 10, 25, 40, 70, really up to 100 kilometers. So you will also, obviously, at each end of the fiber link, you will need to have single mode fiber transceivers installed in your networking equipment at either end. So when you're buying your networking equipment, you will just want to specify, hey, this link I need to go 40 kilometers, for example. So we need to have ports at each end of this fiber link that give me the distance I'm looking for. Main fiber connector types. ST, SC, LC, MTRJ. There are a couple of others, but these are the main 4 that most networking companies build fiber ports for. The LC and the MTRJ are, I guess, relatively recent phenomenon. They have been implemented and developed in the last 10 years. ST and SC have been around much longer. One thing I would mention is that LC and MTRJ are small form factor fiber types, so that the footprint that they would take on any switch is half that of the ST and the SC fiber form factor connector type. So if you're limited by space, you can get a lot more of those. One other thing I would mention about LC, for gigabit, the vast majority of fiber ports and networking products have LC-type connectors. So they're all good. Just depends on what you want. Next slide. So beyond the fiber, you have to look at what the fiber is connected into and the networking products. And in intelligent transportation systems, you're looking at harsh environments. When I mean harsh, I mean temperature uncontrolled environments, outdoors. So you're looking at products that can stand up to wide temperature ranges, -40 degrees Celsius all the way up to 75 or 85 degrees Celsius. So if we look at this picture over on the right, it's an interesting picture. This is a installation down in Florida, and all of these yellow cables you see installed onto the Ethernet switch are fiber cables. So you'll see 1, 2, 3, 4 fiber cables. Each of them have, in this case, SC type of connectors, and there's one little copper cable that also connects into a part of your network here. But in this particular diagram, we've got a unit that's vertically mounted. It's convection cooled. What does that mean? It means that there are no fans. It is vertically mounted on DIN rail. And if you look at the product on the upper left corner, you see right here a little bit of DIN rail. So when you're installing the equipment into traffic control boxes, one of the things you might look at is how is it going to be mounted? Is there DIN rail? Should there be a DIN rail bracket with the networking equipment that you're buying? So that's another consideration. And in this case, this particular unit, because it's installed in Florida, it has conformal coating on the circuit board. So that allows the product to stand up to humidity and tropical in a tropical environment. So compact size for tight spaces, convection cooling, conformal coating, temperature hardened, of course. You can provide a level of redundancy with power options so that if you have one power failure, you can compensate for that with a backup. And I can tell you that in my conversations with engineers that they have told me that products that are convection cooled as opposed to fan-based can last up to 30% longer. And high availability, everyone's interested in that. They don't want their this to be the weakest link, but rather the strongest link, so that's another consideration. You see on this slide a few of the hardened switches and converters available. You've got on the left a couple of switches that incorporate both fiber ports and copper ports. You've got over here a couple of small edge switches and media converters that incorporate both fiber and copper, and they have a hardened temperature range, generally -40 to 75 or 85 degrees Celsius. So NEMA TS2, that is the basic standard that we're looking for transportation networking. And that one of the things we look for when we do the tests, and we have the tests go through for our products, is how it stands up to harsh environmental conditions. So you can read about it here. The next slide talks about a letter of compliance for a particular switch that we manufacture. We're looking at environmental requirements, how it can stand up when you have different surges, extreme temperatures, things like that. So these are not off-the-shelf products. These are products that are designed to be put into an ITS application. You can put them in and hopefully forget it. So now I want to go through a few different applications where we've installed our products, the first of which is the city of San Francisco. And in this particular case, we have got at each intersection, you can see the words here, I hope, P62F, P62F, P62F. those are all hardened switches, and they provide connections to the cameras and the traffic control equipment at each intersection. So it's an application where you've got 2 fiber ports at each intersection. One fiber port is used to connect to the other intersections, give you the distance you need. Obviously, intersections are far apart. So generally 2 kilometers at the least is what you need. Maybe you need single mode fiber to give you more than that. And then what you've got is you've got a single mode fiber link back to the traffic control center. So you need some distance there too. These particular switches have also integrated copper. So this particular switch we've got, it's a P62F. It's a 6 and 2, 6 copper, 2 fiber, and the copper link onto cameras that are at each of the 4 sides of an intersection. So we'll get into copper more later, but switches that incorporate copper at the local level or at each intersection in this case, and fiber going to the backbone and to interconnect the different intersections. That is a type of product that we've used with great success for ITS networking. Fiber networking on the Tampa Expressway, another application. So here's an application. It's very interesting. You've got a new 3-lane expressway in Tampa where the lanes reverse direction from morning to night, so that when commuters come into Tampa from the suburbs in the morning, you've got these 3 extra lanes. When they leave to go out to the suburbs at night, you've got the 3 extra lanes going in their direction then as well. So you've got, what do you have here? You've got redundant fiber rings for traffic control. You've got dynamic messaging signs, sensors, video surveillance. If you look right here at the part of the diagram, it shows 1,000 megabit, in other words, gigabit fiber backbone. Hopefully you can see the cursor dragging through these top 5 6K16B Ethernet switches. So those switches are connected into the backbone. And that's what we like to use and what we recommend for ITS applications, to have gigabit fiber, or at least 100 megabit fiber on the backbone. So these switches are all connected there, and then they go into the TMC, or the Traffic Control Center. The bottom rings, A, B, C, D, E, those are connected with 100 megabit fiber, and then they aggregate onto the gigabit fiber backbone. So what we've got here, if you look over in the left of this diagram, managed Magnum 6K16B managed switches offer Rabbit spanning tree. So that's a software that's in all of these managed switches that allows for quick recovery in the event of a fault. So we've got multiple links back to the backbone, and if there's a fault at any one area, you can recover, and recover very quickly within, we're talking about hundreds of milliseconds rather than actual seconds. A couple of hybrid applications as we make the transition from fiber into copper. We have got down here, if you look at the legend right here, you've got a single mode fiber, you've got 10100 Ethernet copper, and you actually have a serial connection on here too. So looking at the yellow right here, you have got fiber links that go from one intersection, in this case intersection 3, up to intersection 2, intersection 1, and then it goes back to the traffic control center. So once again, you're talking about 2 kilometers distance, really up to 100 kilometers distance. Obviously, these intersections aren't right next to each other, so you're talking about kilometers rather than meters. If you look at 10100 Ethernet copper, at the local level, that's what a lot of the ports in the traffic control equipment in the cameras are. So you want to have a switch that incorporates both fiber and copper. The copper connects back into the traffic controllers, be it a 170, 2070, what have you, and the cameras as well. So you've got the blue here, intersection 3, intersection 1, intersection 2. And you also have a green serial link. So you've got one of the intersections I guess you've got traffic control equipment that only has a serial port, and that connects back to the traffic ops center, and it connects into some product, be it a serial device router, a terminal server, or something of that nature. The last application I'd like to talk about is the City of West Des Moines. So we talk about a lot of different technologies here, and in terms of at the local level, hopefully you can see my cursor here, you've got an ITS blade and a 6K-Q. Those are switches, and they connect here to the cameras, they connect to the traffic control equipment, and they do the job that you need. Obviously 100 meters for copper wiring, or 328 feet. So, and you've got those type of ports built into your traffic control equipment and your cameras. So that's what you need at that local level generally. Then you've got each of these different intersections connected up into multiple rings in the city, and that is connected via 100 megabit Ethernet fiber cabling that goes back to the traffic control center. Then that traffic control center is linked to a higher data rate network, which is gigabit Ethernet, and that connects to the various buildings on the government network, public works, fire station, library, etc. We also have maintenance trucks here that are able to connect into this Ethernet radio in the center and then onto the main network. So you're looking, so fiber is used more for the backbone to give you the distance you need, and also provides a security option, and certainly in environments where you have electromagnetic interference, it can get rid of that. Copper more at the local level, which we'll get into, and there's also a place for wireless as well in this. But I will turn it over, and we can go into copper details.
All right. Thank you very much, Jim. Next will be Paul Heropoulos. He's the Director of Sales for Enable-It. He has over 25 years of marketing and sales experience, and is armed with a BS degree from Purdue University and an MS from Rensselaer Polytechnic Institute. With experience, he's been in the technical world from mainframes to PCs. So Paul, welcome, and you can take over.
Paul, are you there? We're seeing your screen, but we're not hearing you,
yes,
your
I'm
audio.
Here.
Okay,
I'm
there
here.
we go.
I had the mute button on. I was talking to myself. I hope everybody, can everybody see my slides?
Yes.
Okay. So today we're going to talk about Ethernet extenders, why they are needed, and how they will help you. We'll talk about a couple of Enable-It Ethernet extender products, and then some applications. Fiber and wireless have their own advantages. Copper does have one advantage that they don't have, and that's they can send power over Ethernet. And there is another distinct advantage. Copper is already installed in many, probably most locations. Let's see. All right. There we go. In computer networking, it comes down to this. No matter what category of cabling, not including fiber or wireless, there's a specification that states Ethernet should run over a maximum of 328 feet or 100 meters. You may get a slightly longer distance depending on your copper cable, but you're gambling. To go farther, you need an extension cord, but that name is already taken. So you need what we call an Ethernet extension cord or an Ethernet extender. And here you can see the various types of cables, how many pairs of wire are required, their speed. They all have different numbers on them, but the length is consistent. At 328 feet, 100 meters, that's as far as you go. So when to use an Ethernet extender? In simplest terms, anytime your connection is more than 328 feet. You can use it to leverage your less expensive copper wire. You can provide power to PoE devices at the remote location. And you can actually extend your fiber and wireless connections using Ethernet extenders. Why use them? Well, we're all in the business to get more business. Ethernet extenders can help you win bids because they eliminate the need for installing expensive repeaters or expensive Cat5 or Cat6 cabling. Certainly our Ethernet extenders take advantage of the technology that's there, but you can also use existing wiring, whether it's coax, Cat2, Cat3, unshielded twisted pair, and so on. This saves your client time and money, which means you can be the low bidder and help you get the business. Okay, we have a couple of our main products are the 860 and the 865. These are elegant, plug-and-play, made-in-the-USA products that will help make it easier for you to do more projects and to win bids, as I talked about earlier. With the 860's ability to create an Ethernet connection up to 6,000 feet, which is 1.8 kilometers, and its 865 cousin, which drives PoE up to 2,500 feet, 762 meters away. These products are the bread and butter of Enable-It's Ethernet extension menu. They're very simple but elegant products. Here's an example of how the 860 can be used. Each 860 kit comes with what we call a CO, or local device, and a CPE, or remote device. It's a complete solution. Each of these units that you see on the screen right here are about the size of a man's hand. The 860 is the IP version, so both the CO requires power and the CPE requires power. The CO can be up to 328 feet, 100 meters from the LAN, and each of the devices connected to the remote 860 can be up to 328 feet away. You can have up to 4 devices, and the distance from the local to the remote can be up to 6,000 feet, and it's both voice and data. 100 megabits at 700 feet, and at 6,000 feet it's 30 megabits per second. Still some incredible speeds. And I want to repeat, it's a complete solution, plug and play, made in the United States, 4-year warranty, and it has some excellent operational temperatures to work under, from minus 49 degrees Fahrenheit to 168, or minus 45 centigrade to 76 degrees centigrade. Its cousin is the PoE product, the 865. And you can see it's fairly similar to the 860. You have a complete solution, the CO and the CPE. The big difference is everything to the right of where my cursor is, these products right here, other than a switch, no power is required because the power is supplied by the injector, which is connected to the CO, sent up to 2,500 feet away to the CPE unit to drive a wireless, to drive a camera, or to drive any IP PoE devices. You can have, again, up to 4 devices, and it can be any combination of all 4 PoE or a combination of IP and PoE. And like on the 860, the injector can be up to 100 meters from the LAN, and each of these devices can be up to 100 meters from the CPE unit. Sometimes you need more ports. The 860 and 865 each have 4 ports, but sometimes you need a lot more, especially in apartments or warehouses, and even some traffic situations. So we have what's called the 8950, which is the 860 on steroids, and the 8955, which is like the 865 on steroids. It's equivalent to 8 860s or 8 865 COs in one box. And they have the same technical specifications that I talked about earlier for the 860 and the 865. I didn't mention all of our products, but here's a quick comparison. You can see the 860 and 865 that I talked about, the 8950 and the 8955. You can see their max speed is the same. The distances are identical. The max distance, I said, are identical. And then PoE support there's no PoE on the 860 or the 8950. There is PoE Plus on the 865 and the 8955. I didn't mention 2 products. This is our gigabit extender, which has one port, can go up to 500 meters, and then our 820, which is a slower speed and smaller distance, and there are certainly applications for that. Okay, let's look at a couple applications of how these come into play, and I'm going to address 3 areas: security, traffic, and then a campus-type environment. So the security industry is a great market for Ethernet extenders. Cameras are everywhere. Customers are adding them at an incredible pace, and converting coax-based cameras to IP-based PTZ cameras, in many cases requiring PoE to avoid running another expensive power drop. Category 5 wiring is not always available, so the system can take advantage of installed wiring or the installed copper or installed coax. And you can see in this building, each of these blue squares represents where a camera could be, so they can take advantage of the existing wiring in the facility and even go out to the parking lot. Here's a traffic application. There's a lot of detail on this. I'm not going to spend a lot of time, but you get a good idea of how it works. Starting up here is a connection from the previous intersection to the current intersection. Here's a traffic light control box. And there's a PoE switch here to provide power to all the necessary components of this intersection. This goes on to the next intersection. And then there's also, as I mentioned, there's PoE. So it signals 1, 3, and 4. The PoE is there to drive the cameras on each of these devices. Then we have a different option to drive the camera on this device. This is what happens. This is a typical example of a school campus. It could be a shopping center, an office park, a warehouse, a high-rise building, or complicated intersections throughout the city. The campus wants to connect all of its buildings, which you can see there are many. They want to offer Wi-Fi services across the campus. They want to place security cameras throughout the campus. They want to share a single internet connection that starts in Building D, which is administration building. And they want to use the existing telephone network. In other words, they want to keep their costs down and use what's already available to them. So the first step is to place the 8950, which I talked about briefly, which is the equivalent of 8 860s in one box. And they're able to connect each of the office buildings, the football field, all back to this one box using existing cable. And then the 8950 right here in the red connects to the BMOC. And yes, that's not the big man on campus, it's the big machine on campus. That's what all these different facilities have to connect to. Obviously, some of these buildings have additional requirements, so they can extend from each of the nodes that came into their facility. And you can see in this case with the red boxes where they added PoE, and whatever rose-colored boxes is where they added more connections, so they have more internet connections back to the main building. You need to get power to some places that may not have power. For example, the software field or the parking lot or the location out here that looks like in the middle of GNF, which is where they're going to install some wireless capabilities. And then here's the final picture of how this campus has been put together. The circles indicate wireless opportunities, and all this originating from the 8950 that was installed using the existing copper connection. So all of these boxes are cost at MSRP less than $10,000 for this solution, and it's using the existing wiring at the campus. We have other products available from Enable It, mid-span injectors, reducers to reduce the amount of power going to a device at the remote end, lightning protectors, and custom solutions. So what I'd like to say is there's no substitute for expertise. If you have any questions, which we may not have time to address today, there's my contact information. And with that, I'll hand it back to Steve, who will push us on to the wireless people.
Thanks a lot, Paul. And yeah, we'll move right into the wireless. We'll be talking with Kyle Foss from Incom Wireless. Kyle's the technical sales representative for Incom. He's been with the company for 3 years. In his first year, he worked at a production level, getting to know the product inside and out before stepping into his current role as an outside sales representative. He's responsible for the Midwest portion of the United States. Kyle, welcome, and take it away.
Very good. Everybody hear me okay? And do I have some pretty pictures up on the screen here?
Might speak up just a little bit, please.
All right. So here we go. We'll try this out. So first up, I'd like to just take a quick second, thank the guys at Rhythm. I think all 3 of our panelists really appreciate the opportunity to connect with some end users here and just kind of give an overview of what the options are that how we can communicate today. So thank you very much, guys. Greatly appreciate the time you've given us today.
We did have someone said that they're still having a little trouble hearing you.
Okay.
You can talk louder, but
I'm going to have to put the mic in my mouth if I get any closer here, but see what I can do here. All right, guys, so start up. Yeah. Is she going? All right, so I just want to start up with a quick idea of exactly who NCOM Wireless is. We're a manufacturer, first and foremost, of both narrow and broadband solutions within the wireless industry. We've been in the ITS industry for over 20 years as a company now. We started out as a company just looking to get a solution for the oil industry. Had a couple questions from the city of Calgary as to how we could do some communications within the traffic network. Things went really well for us, and we've continued along that stream since. So what are some of the benefits of wireless? First and foremost, it's nice that it's an above-ground solution. Construction costs are absolutely minimal with wireless. You can have an installation done in an afternoon. Very reliable technology. Years ago there was a lot of questions on issues with security with wireless, people getting into networks and stuff. Today, as you see, wireless is everywhere. This is really not much of an issue anymore, as long as you have all the highest security parameters on your networks. Big thing we're still seeing a lot of is some of the old infrastructure out there. People are still leasing lines off of people of different cell phone and cable companies. Well, with wireless technology, you have full ownership of your own network. You can cut any ongoing costs that you might be looking at. So it's a very fast return on investment by switching over to the wireless if you're using any lease lines out there. Maintenance-wise on them, very simple as well. If anything goes down, it's very easy to put a new unit up or just do a reprogram on these things. Just as simple as resetting your router at home if your internet happens to crash on you. So where are we seeing these applications today? Pretty much everywhere you can think of. ITS is our strongest. We do a lot of things, video surveillance, with all the different PTZ cameras out there, video detection systems. We're getting into the utilities market now, a lot of wastewater management. We're branching off the fiber to curb, so again, playing with the different wired infrastructures out there. Building-to-building communications, building up private networks within different things like universities, hospital campuses. So a lot of different places you're seeing the technologies used today. So there's three main types of solutions that you're going to see within the wireless industry today. You have your serial solutions, a narrow band, your higher bandwidth Ethernet solutions, and then there's also your contact closure solutions, which are your on-off applications. So quickly into the serial solution side of things. These are a 900 megahertz frequency hopping radio. This is in the license-free band as well, so you're not going to have to go looking for any special permissions or anything like that to put these radios up. You can use these in a point-to-point system where it's just one radio talking to another. You can use it in a point-to-multipoint as well situation where you're going to have one master location bringing in a range of data from multiple locations out in the field. If you do have any issues with line of sight or if there happens to be some large obstruction getting in your way, all these radios are capable of store and forward, so you can set these up as a repeater. So if you need to get around a corner or around a building, all you have to do is set one repeater station. It's going to take the information from anything coming to it, save that, and store it, pass it on again to the next one. Range on these units, you can get up to 20 miles. I've seen it even go further. Obviously, this does have to do with what kind of antennas are on there, what type of obstructions you have out in there. The preliminary design going into a wireless network is always a very important thing. You don't just want to go set up anything out there without looking at what you're going to be doing first. Within the 5000 series of radios on the 900 end, you're getting up to 115 kilobytes per second of sustained data throughput on these. So more than enough for just controller data. That's your typical setup with these. You're going to see them just being, if you have copper or your fiber happens to be to a certain point in your city, but you have a new suburb that's come up and you want to bring them online without having to do the trenching systems, you can bring these intersections on one by one and tie back into that wired infrastructure that you already have out there. So as I was just saying, a lot of extension off twisted pair and fiber networks. We're getting a lot more interest in the telemetry and SCADA industries and utilities, once again, I mentioned. Just an idea to paint a picture. Calgary, Alberta, where we're born and raised. You'll all be happy to know, anyone down in the States today, we got our first big dump of snow. It took me about 15 minutes to dig my car out this morning, so it's beautiful here again. But we had an install, this was about a year ago. 8 miles worth of roadway across one of the major arteries in Calgary, Alberta. We had 10 intersections they wanted to bring online. Cost effectiveness for this was a lot smarter for them to go wireless. So we had this entire install up in 4 days. The entire project, which included going through purchasing, system design work, and installation, we had the entire thing up within 1 month. Generally, just to get approvals through purchasing, that could take even longer than that. So very quick turnaround to these projects. On to the broadband side of things. These are industrial Ethernet radios. Similar fashion, still your own private own network. These are when you're going to want higher bandwidth applications, when you're bringing things like video online or tying multiple devices in. Frequencies available within the Ethernet realm that we play in are the 900 megahertz, 2.4 gigahertz, often used for Wi-Fi hotspots. The 5.8 gigahertz is the highest capacity right now, so your average is about 108 megabit worth of throughput across on this, so more than enough to bring a couple dozen cameras online. And then there's also the 4.9 gigahertz frequency. Now, this is the only licensed frequency that we are currently playing in. This is often used by different public safety, like police, fire, and ambulance works will use these. Public transit as well, for signal priority, will use this frequency. As I was saying, very high bandwidth. You can get a lot of video across these. With the new 802.11n protocols, that's even if you go to Best Buy to pick up the newest, latest, greatest wireless router for your house and you want to have your Xbox online with your computer, streaming video, passing pictures across. The N routers are the most powerful. It's the newest protocol out there. So with these radios now, you can get up to 300 megabits across these. They're near or non-line of sight, again, dependent on what frequency you want to play in and what you want to do with it. Same applications that you can have with the serial radios, where you have the ability to store and forward. You can do point-to-point setups, so just one radio to another, or multi-point setups, which I'll get into a little more details here. And again, with reliability and security on your network, all radios, this will be across the board with anybody. You're going to see the highest security using different 128-bit encryptions, different authentications, all password encrypted. I won't get into the details on that. That's for our engineers. So just to give you an idea, paint the picture again of what you'd be looking at in a broadband network, there's multiple unit types that you can look at. On your right-hand side, over here, you have an integrated radio. So this has the actual radio housed in with the antenna. So that diamond-looking shape, that shreddy you see up on there, that is a 23 dB gain antenna. Very powerful laser-sighted antenna. You're going to get really strong signal and good distance off of these. Those are often used in a remote location, a remote or a slave location, you'd be calling that. Your master unit would generally be one of these guys over here. These connectorized units have 1 to 2 antenna ports open on it, giving you a lot more flexibility onto what you want to do. So if we look into the next slide here, you have different options with your antennas. So if you look at that panel that I was just discussing, that's a very narrow beam width, similar to a laser beam. These things are just shooting as strong as they possibly can in a very narrow direction. If you look at a sectoral antenna, these guys have a much wider beam width. They don't have as high a gain, but they're great for master locations where you're going to be having 4 or 5 panels pointing at the same area. So these guys are adjustable from a 45 up to 180 degrees. So you'll stick 1 or 2 of these on at a master location, and you can pick up a wide array of radios from different areas. Again, just kind of showing what we're doing nowadays. Often at your traffic management center, similar to Calgary, what we have set up here. Traffic management center is just going to have one of these 5.8 gigahertz radios. Great places to place these are any high point in land. So we use, a lot of cities have great water towers, and we use those often. If you have radio towers, those are great as well. You get those radios up there, and you can reach pretty much any intersection across your city. So this is great where if you have an instance where you have 1 or 2 going down, or if your fiber or your copper has been cut for whatever reason, You can beam right back up to the tower, and you don't even have to. It's an afternoon worth of work. You got the radios back up online, and your intersections are giving you full communication. Something else that we've gone to outside of the ITS industry is a little more building-to-building communications. One example of this, we just linked up an entire campus at a hospital just in northern BC. So what these guys wanted was full network access, but not Wi-Fi across it. So all these buildings have incredibly high bandwidth across all of them using the 5.8 gigahertz frequencies again. They're getting 100 meg worth of throughput going back and forth through all the buildings, giving them more than enough space to go playing with anything they have. By using the 5.8 gigahertz frequency as well, any of the laptops and stuff you see are not going to be even picking this frequency up whatsoever. So this frequency is locked into their hospital, and nobody else is going to be seeing it that happens to be in the area. Give you an idea, just one of the kind of barriers that we face is people are always worried about programming these radios. If you don't happen to be the most tech-savvy individual, it's not a problem at all. Software interface to programming these is very simple and friendly to use now. The most current we have out now is called Stratos. It's got a full mapping interface on it, so you're able to actually plot every individual intersection, label them whether they're masters, remotes, you name it. It's going to give you your signal strength on your antenna right at the bottom. So when you first go out to deploy these radios, all you have to do is point it general direction, and as those green bars get stronger and stronger, once you have that strong signal, you just lock it in, tighten the bolts, and you have your signal. As for the throughput on it, all you have to do is hit start on this little panel right here, and it's just going to give you an average amount of megabits per second that's going across this network. All the data, all your parameters are just saved right here on the right side. Everything's configurable from one page. Very easy to use. And the last type of solution is the on-off solutions that we see using our contact closure radios. So the contact closure radios built off our 900 megahertz serial radios. They're adjustable from 1 milliwatt up to 1,000, so a full watt. They're ground-activated IOs using 0 to 24 volts. So you have 8 on there. Point-to-multipoint, point-to-point systems again. Fully encrypted, and they are very low power consumption. So you'll see a lot of these applications are using solar, and there's no problem at all on these because they barely will even register in the system that you have set up if you're using solar power. So a couple things that we've done this with. Fire hall preemption's been a big one where they'll have one master unit located within their fire hall and an array of beacons around the fire hall. Once the call comes in and they need to get the trucks out, all they have to do is activate that master unit within their fire hall. All the beacons turn on outside, instantly warning any passerby that there are trucks going to be coming out soon. Another one is the way station applications where all the highways have these for the trucks. If you want to bring them in, same thing, simple activation unit can do this. Bridge warning systems at the main point. Once the bridge lights go on, our contact closure will pick up the little relay signal. It's going to pop all the beacons on around your bridge, and you're safe to cross. One of the newest things that we're seeing now today is in the States, you're now legislated to have beacons in all the school zones. We've now developed a new product for this called the WebIO. This is an Ethernet gateway, so this device can be accessed as long as you have an internet connection anywhere. So what this does is it's going to take a year's schedule for all the beacons in the area that you want to label at the schools, download that into each individual beacon out in the field. These beacons are now going to be completely autonomous. Should you lose communication to the master for whatever reason, crazy driver happens to knock down one of your poles, no problem at all. These are completely autonomous once that schedule has been downloaded. If it happens to be a bad snow day and school's canceled, you need to turn the beacons off. No problem at all. All you have to do is pick up your laptop, set in the IP address, bring that unit up, and you can turn all of them off from home. So very simple, intuitive system, making a lot of headway down in the States lately with this project. So that's about it for myself. Thank you very much for listening, giving us the time, and I'll pass this back on to Rhythm.
All right, great. Thank you very much. Now we'd like to open things up to some questions from the audience. We've received a few questions during the session, and we'll go ahead and answer those first. And if you have any other questions, this is a good time to submit them, and we will work through them. We've run a little bit over the original time, but we can go for at least another 10 or 15 minutes answering questions. I will start with one of the first questions someone was asking me about in my section where I was talking about general internet technologies, why I didn't mention UDP, which is TCP and UDP are two different low-level transport protocols. And I basically, there are many 3- and 4-letter acronyms associated with this, and I was trying to keep it straightforward, but yes, the basics of network connections, you can do lots of different protocols. Like I said, the impressive things about these things are that it's really agnostic as to what you're transmitting across your wires. It just carries whatever you want and it gets it there. One of the next questions we had was with regard to fiber optics technology. They were asking what the requirements are for the conduit as far as turning radius. Can we use the existing interconnect conduit and install fiber in those conduits? Do you want to answer that one, Jim?
You know, you've got my contact information here. I can jim@garrettcom.com. I can take a look and talk to some of our engineers, and if they don't know, the install guys. But my main focus there for the conduit was that fiber optics are so small that you can fit so many in and take advantage where you have small spaces. But in terms of the radius question, I'll have to get back to you. So you can email me directly if you'd like.
Okay. The next question we had here was with regard to wireless. We have several wireless questions here. The first was asking about near and non-line of sight for broadband radios. What do you mean by non-line of sight? What do you mean by that terminology?
Depending on which frequency and what you're going to be doing with your network, the lower the frequency, so let's start at the 900 megahertz end, that frequency is a non-line of sight. There's points where you can actually get through building. If you have foliage in the way, that's not an issue. So the 900 megahertz frequency has the ability to bounce off of other objects and make it back to the original point. As you get higher up in the frequency, so once you're up to the 5.8 gigahertz frequency, since there's so much data and it's such critical data going across that, that frequency doesn't have the same non-line of sight frequency or properties. So in that case, it's a lot more important to have a nice clear shot. Luckily, within the ITS industry, that's usually not much of an issue because we're jumping down roadways, which happen to have nothing in our way. They're nice and straight built, so it's perfect for that. But that's, as non-line of sight, you're going to be looking at a lower frequency where you're going to get less data across there. And as you get higher in frequency, it's more important to have a nice clear shot with line of sight.
So somewhat related to that, a question from another individual on here was asking how street trees interfere with the wireless signal installs. Is it a big deal? Is there a lot of interference or little? And what's a workaround?
So again, that's if you're using a 900 megahertz frequency, it's generally not much of an issue. We've gone through trees, no problem. As you get higher up, if you're at the 5.8 frequency and you want to be bringing back a lot of video, it is more finicky when you get in the way of things like that. So that's where it's helpful to get up on a tower where you can get over the tree line and shoot back down to the individual points. So yes, trees can affect the wireless signal for sure if you're at a high gigahertz frequency.
Right. Another person was asking about the slide presentations, and we will be posting the entire presentation that you'll be able to play through again sometime later. How soon usually?
Yeah, within the next couple of days or so. We have your email addresses when you registered, and we will send you the link to that.
All right. We also have one more question here for Jim asking about is the fiber speed determined by the fiber design or the device it is plugged into? And if it is the fiber, how do you tell what is installed?
Well, the fiber speed is basically determined by the transistors that you have on each end of the fiber link. So, so if you install a fiber wire and you connect it into two fast Ethernet switches, that's 100 megabits, one Ethernet switch on one end, one Ethernet switch on the other, you're going to get 100 megabit. There are fiber wires that are both multi-mode and single mode. the multi-mode obviously can go 2 kilometers, a single mode much more, depending on the transceiver that is in the fiber switches. So you do have fiber cables at 10, 100 gigabit Ethernet. So the same cables can be used across different data rates. So the speed is really determined by the products connected at each end, meaning the switches and the transceivers on the switch ports.
All right, thanks. We had another question. The audience was asking what you would recommend for VPN and signal controller boxes. We have used quite a few technologies here at different locations where we've deployed our Rhythm products. Cisco is obviously commonly used technology. They've been around for quite a few years and are well understood. And in general, I would say a lot of this is also going to be dictated by your IT department, or if you suspect at any point you're going to be working with larger networks, it's certainly worth talking to other agencies that you might be interacting with to see if there's a common technology you'd want to use. Other VPN solutions we've had, we make use of some hardware called MikroTik routers. They make use of a thing called a point-to-point tunneling protocol, which has worked quite well for us. There are literally probably a dozen different solutions available out there. I believe Greenbow is another technology we've run into, and there have been, I'm trying to recall, there's one other that we've made use of, name eludes me, but really pretty much all of the VPN technologies, it's a very stable technology, the concepts, and any of them really will probably work quite well for you. Let's see, we've got a couple more questions here about, there's one here for Jim asking, is single mode fiber required to go faster?
It is not required to go faster, but it is required to go longer. So if you want to go longer than 2 kilometers, which you can go for with multi-mode fiber, you need to connect in with products that have transceivers that will go the single mode distances, be it 10, 25, 40, 70 kilometers and beyond. So single mode is not required to go faster, but it is required to go longer distances. You can go 100 megabits or gigabit with both multi-mode and single mode fiber.
Right. Had a question from an audience member about a follow-up on the Cisco, asking if the Cisco ASA VPN boxes are capable of handling the environment in signal boxes. Honestly, I'm not an expert on Cisco equipment, so I'm not going to be able to tell you off the top of my head. I can look into it, or honestly, talking to a Cisco rep, he would be able to give you probably even better information than I can. But I will. I have your name here, and I will see what information I can get you on that. Let's see, another question here. This one's for Kyle, asking about the major challenges you often face when deploying wireless networks. What are the things to watch out for?
Biggest things to watch out for, first and foremost, is you just want to know what exactly you're going to be bringing across your network. We've had people try and flood their network with too much video with not proper design. So number one is to see what exactly do you want to bring online. That's the first thing that we want to address. After that, the next thing to do is where are all these intersections going to be bringing online, and where do we have to get that back to? So that's where the design end of things comes in. One of my areas that I've been working for a while now is the actual train analysis. So once I'm given a certain amount of intersections, I can take a look via Google Earth with other softwares, see what the mapping is going to be looking like, find out what the best routes are going to be to get all the information back. So number one, again, is going to be what do you want to do with it? And then number two, how are you going to do it? So again, just the obstructions you got to be looking for. We've done one of our largest deployments is in Burnaby, BC, where it is as hilly as you can get. BC is known for just massive trees, so that was quite the challenge for us. The terrain layout was very difficult to work with, but now we've got 300 of their intersections online, and they couldn't be happier with us. So I'd say the biggest challenges are just what do you want to bring across it, and how are we going to get all that data back? So just the different terrain challenges we have.
All right. We have a couple of questions from individuals asking for contact information with some of these companies. I would recommend if you look on the slide that's showing right here, we have email addresses for all the individuals and phone numbers for individuals that you can get that kind of information. And of course, we'll be sending some follow-up emails to you that will provide some of that. I had another question here asking about how many deployments do you know that are using broadband connections rather than direct fiber or copper? I suspect what you're asking about is making use of, common connections like a DSL line or a cable modem or something like that. And I know with our particular product, we do that fairly commonly, actually. We have specifically designed our product to be to work around web interfaces so that we're able to make use of whatever bandwidth is available. And so for the video that we're pulling back for traffic purposes, we're not actually streaming a full 24 frame per second video. We're pulling back data at whatever rate we can get it to. So typically you'll see a screen refresh every second or so, which is generally not how you'd want to watch a movie, but it works quite well when you're watching cars driving down the road. So we've had really good luck making use of that. And from our offices here in Kansas, we're able to connect across the internet into a VPN connection in locations such as Evans, Georgia, Grapevine, Texas, San Ramon, California, and have had all of those make use of different specific connections. Some of them have fiber within their local ITS network. In Evans, they make use of wireless and fiber. In some of our intersections in Topeka, we've made use of they've made use of exclusively wireless technologies. We've made use of Enable-It technologies in California, and all of them have performed quite well for us. So really, I think it's mainly about what is available to you, as what's already there that you want to take advantage of, and what works well for you. The one other thing to consider is if you do have a convenient connection, it is, of course, easier to hook into an existing network system. And if you are using things like a DSL or a cable connection, that is an ongoing, although very low price, monthly cost, probably something in the $100 range a month. But it would be a recurring cost that you'd have to pay. Okay, well, I believe that's all of the questions we have, and I'd like to thank all of our panelists for joining us today, and I'd like to thank all of you for coming and attending our presentation. As we said, we will be posting this on the Rhythm website. This entire presentation will be available to you later on in the next day or so, and we appreciate your time and hope you all have a great day.
Thank you very much.
Rhythm Engineering
Has left.